In this video, we are going to discuss about Doraemon problem. It was asked in January challenge 2020, long challenge. Okay, so what is the question? The question is given a matrix of m into n of n into m, that is n rows and m columns. What we need to do is you need to find the number of pairs of sub row and some column and sub column with the following properties. And what are the properties? Now we have to select the sub row and the sum column, and those sub row and sum column will form a pair, and those should follow these four properties. And what are the four properties? That both sequences have the same length, that is an odd length. That is the second point, odd length. Okay, the central element of both sequences are same, and both sequences are palindrome. Fine. So what is the meaning of this is that first point is both sequences should have an odd length. For example, I cannot select these two, that is 2 and 1. I cannot select this because it is an even length sub row. Okay, I can select 2 1 2. I can select 2 1 2, and this is an odd length. The central element of this sub row is nothing but 1. Okay, I can select this one of length 3. Sub row and sum column of the same length, both are odd, but here the central element is this. The question says is the central element of both sequences are same, they correspond to the same element in the matrix, but it is not happening here. It is not happening here. Correct? I selected this sub row and this sub column. Okay, they both are palindromes. They both have the length 3, which is odd, and both have the same length also, but their central elements are different. They are not at the same position. Okay, there is not same elements in the matrix. Fine. So therefore we cannot select such rows and such subcolumns. Okay, fine. Similarly, I cannot select anything from this row because obviously we have this one, and if I select this, we have this same case. I cannot select anything here because the center element will never match. I hope you are seeing where I am going with this. Now obviously we can select each and every as a single row and a single subcolumn. We can select everyone as a single row and a single subcolumn. Fine. 1 is an odd length, both have the same sequences. If I select 2, okay, single row, single subcolumn, okay, both have the length same, both have a single one element that is same, that is nothing but 2 itself. So yes, we have the answer as 1 2 3 4 5 6 7 8 9. Definitely there are 7 rows and 7 subcolumn pairs. Fine, that will follow all these four properties. So 7 is definitely one of the answer. That is, in the count we will add 7 without thinking anything. Fine. So we got actually our first part, that whenever a question is given to you, the count of the sub row and sub column will definitely begin with n into m. Okay, I think it is 9, not 7, sorry. N into m is 9. So 1 2 3 4 5 6 7 8 and 9. So here the answer is 9. So not the answer, but we have to count becomes 9. That is, directly it becomes 9 because one length will definitely follow all the four properties. Now what can we select? The next one, we can select this and we can select this. Now as you can see, both are palindromes, both the sub row and the sub columns are palindromes, and the center element is the same, so we can select this. So the answer becomes 10. There is nothing else we can select, you can see. So therefore in the test case that they have provided to us, the answer is simply 10. Fine. So this was the problem statement. Now what is the constraints? T is 100, n into m will be less than or equal to 10 to the power of 5. So T is 100, n cross m will be less than or equal to 10 to the power of 5, and in all the test cases the n into m, sum of all n into m, will never exceed 3 into 10 to the power of 5. Okay, that is 3 lakh. Okay, it will never exceed this amount in all the test cases combined. Fine. So n into m to become 10 to the power of 5, so that will be 1000 into 100 or 100 into 1000. 100 into 1000. Anything else? There are much more combinations, but 100, this is one perfect combination, that one of the n or m column will be 1000 and another one will be 100. There are other combinations, but here we get one of the maximum values, that is 1000. Okay, so obviously this will have at least n square complexity, at least I am saying, because we have to access the rows and columns, so n square will be there. So that is not an issue for us, that is not an issue for us, because the elements will be nothing but 10 to the power of 5. Fine. Now will the n cube be accepted, or will the n to the power of 4 be accepted? Now that is the point. Okay, because we have to do some calculations here and there. So will the n square be enough, or we have to move forward and we need one more loop for that purpose? So that is nothing but the point that is right now remaining. That is the point that is remaining. Okay, let's see that point now. So what will be this n square? If I am running a loop on my rows which are 1000, the columns will definitely be 100 at this point, so it is nothing but 10 to the power of 5, nothing but 10 to the power of 5, a nested loop. Okay, and now inside this loop, now I want to know that how much I can accommodate, how much I can accommodate. If I can accommodate another loop running for 1000 number of times, so that will be 10 to the power of 8, which is acceptable in 1 second. We have 100 test cases along with that, but we also have a case that in all the test cases combined, n into m sum is not more than 3 into 10 to the power of 5. Okay, that means if I have 100 test cases, okay, then this case of 1000 and 100 is maximum 3 times, is maximum, not, I don't think it is even 3 times, because then it will exceed, for the next 97 cases it will exceed 3 into 10 to the power of 5. So we will not have this case, we will have only this case 2 times maximum. Fine. So obviously we can do this 2 into 10 to the power of 8, and then nothing but a constant amount of times. So yes, in 1 second it will be accepted, if even if we have these 3 loops, one is running 1000 number of times, another is 100, and inside it is also running 1000 number of times. So we can accept this much time complexity. Above this there will be problems of TLEs. Fine. So this was the problem statement understanding and the constraints. Now let's begin with the logical part. So let's see the logical building part. So here n is 5, so count will definitely start with 25, that is these 25 elements when taken length equals to 1. Now we know that there is no need to select the row 1 and the column 1 and the last row and the last column, because obviously they will never have a can have a palindrome, but the middle element will never be common with any other row and column. Fine. So we will begin with this row, that is the second row and the second column. Fine. So after beginning with the second row and the second column, now what can be a brute force approach? Now I think a brute force approach is very direct. A brute force approach here is very direct. Okay. So for each row, okay, we need to select, if 3 are possible, then select the 3 elements. Okay. Then a column also, select these 3 elements, check whether they are palindrome or not, and check whether their middle elements are same or not. Then after this, just go for the next elements, that is these 5 elements. Is these 5 elements possible here? No, the 5 elements are not possible. Even if they are possible, that is you go till the end, the middle element will never be the same, so therefore there is no need to check that. Okay, but we did find out this array and created a sub row for that. Okay, and for each time if we do this, so let's see what will be the time complexity of that approach. Let's see what will be the time complexity. So for each row we are accessing this element 1. So for example, a loop I for accessing the row, okay, this element 1. Then we have a j that is accessing this element 1, because we need 1 1 1 also, and we need 1 1 1 1 also. Correct. For this element only, till, if we have 7 elements, so this will go till 7 also. Correct. So for this element only a loop will run. For this element alone a loop will run. Okay, then for the second element the loop will run, because the sub array can start from the second element also. So for a second element also a loop will run. For the third element also a loop will run, till it is possible to run a loop. Okay, so for a j and then a k and then a k, because if j is this and k is this, now k is running these loops, when for the first element it is over, then j will increment to the second element. Okay, and k will start running the loops for the second element, creating a sub row for a second element. Okay, then for the third element. Fine. Now inside this, if you create a sub column and a sub row and then send them into a palindrome function to check whether they are palindrome or not, so order of n inside order of n cube. If it is the largest palindrome, so it will take order of n, that is 10,000 number of times. So 1000, 100, 1000, 100, 1000, so it will be 10 to the power of 4 around, so that will not be accepted. So we cannot form this logic, we cannot move ahead with this logic. It will give us a TLE, it will give us a TLE if we do this part. That is, for each and every element we find the palindrome, we find the corresponding column palindrome or corresponding column row, we check for them as a palindromes and we check for the middle elements. So this will not work, this will not work, we have to think of something else. Okay, so this was the brute force approach, this was the brute force approach, that for each and every column, for each and every row, okay, in that each and every element we run a loop. For each and every row, in that for each and every element we run a loop to check whether to check for the palindromes and sub row and sub columns correspondingly. Okay, as you can see, for the first row, if we have 7, so it will run these many times, it will run these many times, just the first element. Then the second element will run, it will form this, it will form this as a sub row. Okay, if there are more elements, then it will form those also as a sub row. Okay, and it has to check for the corresponding column also at that time. Fine. So yes, this will not work, this will give you a TLE. Now let's move to an optimized approach. So let's see the optimized approach now. Fine. Now if we are here, we're pointing to this location. Okay, now first we just need to check for 3 length, correct? We have already handled the 1 length cases, now we have to check for the 3 length cases. So in the case of 3 length cases, do we need to create sub rows or sub columns? Just ask yourself, if this is my palindrome, okay, if this has to be a palindrome, we cannot do anything for this element because this is just one and the same. Just compare the first and the last element. If they both are same, then this is a palindrome, else it is not a palindrome. Okay, we can do that directly. So for this case, that is for the element present at 1 0 index, at 1 1 and it at 1 2, if we just check for 1 0 and 1 2 they are same or not, and we check for 0 1 and 2 1 are they same or not, then we will find out whether this is a palindrome or not and this is a palindrome or not. And if these two are palindromes, then definitely their middle element is already 1 1, their middle element is already 1 1. So we will find one pair and we will increment the count. Okay, so how do we do this? It's very direct. So as you can see here, I value is 1, j value is 0, I value remains same, j value incremented by 2, I value is decreased here because we are changing the rows, I minus 1, and j value is increased. Here I value is increased and j value is increased for 2 1. If these two are same and these two are same, obviously the middle element is one and the same, so we find out a row, we find out that a subcolumn and sub pair. So we find out a pair, and we increment the count. Fine. Now how do we move forward for the 5 case? That is, how do we move forward for the case when there are 5 elements? Okay, do we increase that? But we have already tried that, that does not work, and this function will not work, that you just check for the first element and the last element. They have 3 elements in the middle. We will use this exactly this point, that if we have 1 1 1 1 and 1, you just cannot check that 1 and 1 are same, then this is a palindrome. No. Okay, for example 1 3 1 2 4 3 1, you cannot say that 1 and 1 are same, then this is a palindrome, this is not a palindrome. Okay, but how can you say this is a palindrome is without forming a subarrays? First check for these elements. Again this is a 3 length, again this is a 3 length, correct? Now for 3 length this is very simple, you have to just check for this, you have to check for this. Now if this is a palindrome, the inside one is a palindrome, now you know that inside you have a palindrome. Okay, now if the boundaries are same, again obviously the whole will also become a palindrome. Fine. So in this case inside is not a palindrome. Okay, so no need to check for the boundaries, that is 1 and 1. Inside it is a palindrome, so just check for the boundaries. If they are also same, so these 5 is a palindrome. For example 2 1 2 1 2. Okay, just check first for this, instead of checking for the 5 length, check for the 3 length. Is this a palindrome? Yes, we can just check for the first and last. Yes, it is a palindrome. If this is a palindrome, then check for 2 and 2. If this is a palindrome, yes, that means all the 5 are palindrome in itself. And in the process we have also checked for this case. In this process we have actually also checked for this case, that is the second elements row and column pair. Okay, now if this is true, then we will check for this case. Okay, obviously in this example for this row we will not have a common element because this 2 1 2 1 2 have a center element here. Okay, so but what I am trying to explain is for 5 length, first we will check for the 3 length. Now checking for the 3 length we already know, and then in checking for the 5 length, again the same formula will be used. Okay, so with some modifications obviously. So this is for the 3 length only. So that is what I was trying to explain. Okay, now if I check for a 7 length case, if I have to check for a 7 length case, for example, it is all ones, 1 2 3 4 5 6 and 7. So first check for a 3 length. If this is a palindrome, check for a 5 length. Now checking for a 5 length is very simple. If the 3 length is palindrome, just check for the first and the last element. If 5 length is also a palindrome, then check for the 7 and last. So if this is also a palindrome, we are simply done. No need to create sub-array and send them into some other palindrome function to check whether it is a palindrome or not. Okay, if conditions take order of 1. And a loop is obviously running. A third loop is running for this purpose. Okay, and in this third loop we have changed from order of n of creating sub rows, sub column, and a palindrome function to check it if they were a palindrome or not. From order of n we change it to order of 1. We already had 3 loops, and this was acceptable. Okay, inside it, from order of n we change it to order of 1 using if conditions. We can do this, we can easily perform this. Now if I go further down, that is here at this position, so here I think you will be easily able to see this, that first we will check for this. Yes, it is a palindrome, it is also a palindrome. I have already explained you how you will check for 3 length cases. Now for a 5 length case, do not check for the 5 length cases. First check for this 1 to 1. Is 1 to 1 and is a palindrome? Yes, it is a palindrome, and corresponding check for its column, we already found a pair. Okay, we found a pair right here. Now if this is a palindrome, now check for these two also and these two also, because this column was a palindrome, this row was a palindrome. We found out their boundary cases are also palindrome or not, also same or not. If they are same, that means this whole process, the whole row and this whole column was also a palindrome, and the center element is 2. So we found one more pair. Now in the case if this was not a palindrome, this was a 2. Okay, now there is no need to check. So this reduces the comparisons, and we do not need to create sub rows and sub columns and check them for a palindrome. Okay, we will use this property of the palindrome, that center should be a palindrome. Then we will move forward to the boundaries, then to the boundaries, and then to the boundaries. Okay, this one 7, first check for 3, then for 5, and then for 7. Okay, let me pick up the pen and then we will start again. Now the logical part is over. That was the logical part. Now let's begin with the implementation part. Okay, how we will actually implement it. Okay, that we are saying that we will check for the middle first, then for the boundary cases, then but how we will implement it. Okay, just quickly see that implementation is different for different people. Okay, this is just my approach to the implementation. Okay, if you have understood the logical part, you can implement it on your own. Try to implement it on your own first. Fine. So the code will be available in GitHub repository for C, C++, and Java. Okay, but try to implement on your own first. Fine. So in the implementation, you can see that a row, a loop for I equals to 1, that will be pointing to the rows. A loop for j equals to 1, that will be pointing to our columns. Okay, we will obviously run for n-1 times and m-1 times. Okay, because we are not starting with the 0th row and we are not going till the end row. Okay, now what we will do after this, now just see this part. Now here we need to tell that beforehand only, we need to tell that whether we need to check for 3 length, 5 length, 7 length or not. Okay, is it useful to check for 5 length? Now for this element, is it useful to check for the 5 length, or for this row, for any element, is it useful to check for 5 length cases? No, it is not. Why? Because the columns will never have a middle element in this row that is of 5 length. Okay, column will never have a 5 length sub row, sub column that have a middle element in this row. Okay, it will be in this row. Fine. So we need to calculate that we just need a single element in this case. We just need only 3 length cases. We do not have to check for the 5 length cases. So the third loop will not run for the 5 length cases, 7 length cases, or 11 length, 9 length cases, and it will not waste the operations. Okay, it will just run for the 3 length cases and it will be done. we have to tell that. So how you will tell that is, it's very simple, it's very actually simple. That first check what are the values of I and j. I and j values both are 1. What is the minimum? 1 is the minimum between them, nothing else. Now just check, after getting this, just check how many elements are present after it and how many elements are present before it. Okay, we need to check only that part. And now if the sufficient elements are present after it and sufficient elements are present before it, for example in this case when I value will be 2 and j value will be 2, there are 2 elements before it and 2 elements after it. That means we can have a middle element at this particular place. Okay, only in that cases we will check for the 5 length case. Only in that case we will check for the 5 length. Okay, now similarly for the 7 length we have to check for, we have to generalize this, we have to somehow generalize it. Now again, this is on you, the implementation part is on you. I will show you the code. Okay, you can dry run that code, you can dry run that code on your own and see how each and every value is being calculated, because explaining the implementation and dry run will take a lot of time. Fine, so you can do that, the logical part is over. Okay, so I will show you the code right now of how it is happening, how I am doing that. Okay, and you can just on any test case, on this test case only you can do that. You will see that after we check for 2 1 2, we will check for 1 2 1. If this is done, then we will check for 2 1 1 2 1. Okay, you will see that when you dry run the code, you will see that, and it is a good approach and a good thing to learn how to dry run anyone's code. Okay, so just you can see different codes and learn from different codes. Okay, first try on your own, okay, first try this process on your own, just the implementation process. Okay, 3 loops, okay, not more than 3 loops. Fine, because the more than 3 loops will give TLE. So now I'm going to show you the code. Okay, and the code is also available in the GitHub repository. So this is the code here, right here. So as you can see, this is just nothing but a single loops for taking, nested loop for taking the inputs. Then a count will begin with n into m directly. Then what I am just doing is I am calculating. Now this is different, I guess this is different for different peoples. Okay, you will see many different codes. If you go to the editorials and you go to the submissions, you will see many different codes. Okay, so this is just one of them. Okay, I am just calculating that how much time this k loop needs to run. I am just calculating for how much time this k loop needs to run. Okay, I am just calculating this min. This can be calculated in a single step also inside this only. Okay, using the min functions. I have just divided into 3 steps for you to make it easier. Okay, so just see that part and nothing else. It's very easy. Fine. So now if this is true, then we will increment the count, else we will break. We do not need to run the loop again and again for that particular element. Fine, else we will simply break it out. Now just after this, just print the count and it is done. Okay, the same codes will be available in other languages, that is C and Java, in the GitHub repository. Fine, again I am telling, I have skipped the part of the implementation because it will take a lot of time to just explain you each and every step what is going on. It is highly recommended that you do that on your own first. After understanding the logic, just do that on your own. Okay, it will be helpful in the future long challenges also. Fine, after that just see this part. After that just dry run and see how it is happening. Okay, it is good to see other codes because they sometimes teach you new things. Fine, and new logic and new different approaches. Okay, if you have any doubt, you can ask in the comments. Okay, thank you.